Hello world, and welcome back to Zara overview and tutorial series. In the last episode, we covered Zara Health Engine in depth, learned how to create new diseases and injuries, how to describe their treatment, learned what are disease monitors, side effects, medical agents, and more. Today, we'll do similar thing with the inventory. This video will touch upon the topics not only obviously inventory related like crafting, but also things like how food and water work in Zara, how to eat and drink, because these topics are directly related to the inventory too. We will not touch upon clothes, because this I leave for a separate video. Okay, let's start. If we look into the inventory folder, we'll see there inventory controller. This thing is responsible for dealing with the inventory itself, crafting and using, consuming or injecting items. We'll look at crafting a bit later. Let's start with inventory items. Every inventory item must implement inventory item interface. This interface contains only the bare bones item info like name, count, type and weight. ID property is a unique identifier being generated for every game session. With this interface on top, Zara has a hierarchy of inventory item base classes, each for every item kind. Inventory item base class is a direct implementation of inventory item interface. It is abstract and just exposes all the properties for its descendants to override. Next, we have three abstract childs: inventory consumable item base, for describing any consumable thing in a game like food or water; inventory tool item base, for describing any tool item like knife, needle and thread, rope, stick; and inventory handheld item base, for describing handheld items like any weapon or whatever case may be. All these classes do is they set the type property, which can be a list of values from this enum. Organic, telling that the item is an organic matter. Tool, telling that the item can be used as a tool. Handheld, for telling that this item can be carried in character's hands. Medical, telling that this item has some kind of medical use. Clothes, telling that this item can be used as clothes. You can combine those types together to describe more precise any item you want. And that's precisely what these descendant classes do. They're setting up the type property for you, and by wrapping it in a dedicated class, make it easier for you to quickly find and inherit the class that describes your item best. All those classes, of course, are abstract. So, if you want to create a new inventory item, you must create a class, inherit from whatever base inventory item class suits you the best in your case, and override things like name and weight, and, of course, set any custom properties base class provides. Some base classes, like for example inventory medical item base, have their own properties that you need to set in your descendant classes. In this case, you need to choose a particular medical kind for your item. Is it a consumable medical item, appliance, or can be used only for crafting and cannot be used directly, like empty syringe? You must combine it with some medicine and then use. Let's look at knife item description. As you can see, its description is that simple. You choose base class and set name and weight, that's it. In this case, base class tells us that this item can be used as a tool, as well as it can be a handheld, serve as a weapon. The only rule here, inventory item name must be unique for every inventory item type. You cannot have two inventory item classes with the same name property inside them. As I said in a first video, Zara uses metric system everywhere, so weight measures in grams. If inventory item class implements inventory infinite item, its count will never be affected by using it or crafting with it, and this item will always pass all resource checks. For such items, count is expected to always be of 1. With that, let's explore a little inventory controller. First thing you see here is a maximum allowed carrying capacity. It is 50 kilos now, but you can change it here. Current weight is a not cached weight of all inventory items. It is calculated as a weight of all non-food and non-water items, plus weight of all fresh food items, plus weight of all spoiled food items, plus weight of all actual water in all water vessels plus weight of water vessels themselves minus weight of the clothes player is wearing. Rough weight property is a cached weight of all inventory items. It is being refreshed every time inventory changes, or you can refresh it manually by calling refresh rough weight method. Why rough? Because since the value was calculated, some food can spoil or character may change its clothes. To get precise inventory weight, use current weight property, but carefully, it is not cached, it is dynamic and so expensive. Below, we see constants for all inventory item names. They are used in name properties of item classes and should be used throughout the game code, so item names are not hard-coded in 1000 places, but only once, here. Of course, inventory has a list of items, but it is recommended to use special methods to operate it. Get by name for getting an item, count off for checking how many items of a given type inventory contains, has item to check if item exists. It's using inventory cache, so this call is not expensive. Add item and remove item. Remove item accepts one optional parameter, count. If this parameter is omitted, item will be simply removed from the inventory. If count is set, waste item method will be called instead, which will check if a given count is less than the count of a given item type, and if so, will only decrease item count. If given count is equal to the item count, then it will remove the whole thing from the inventory. For water items, it will leave item count intact and will work with doses left property. For food items, it will operate on spoiled or fresh food group according to the item name given. More on food and water items in a second. Remove item will never remove water item from the inventory if count is given. Now, when we know inventory basics, we can take a closer look at food and water. Every food item inherits food item base class. Imagine food item as a container with two separate sections where fresh and spoiled items of some particular food kind is stored. Every food item has its food value and water value in percent. These values will be added to characters' food and water levels when one piece of this food item is consumed. If piece is spoiled, only the half of these values will be applied. Let's take a look at sample food item Zara provides. In a constructor, we initialize food poisoning probabilities, separate for fresh and spoiled items. In this case, food and water values are not always the same. They have some random part to make things more dynamic. Minutes until spoiled tells Zara for how long newly generated piece of this food will remain fresh. To add a new piece of food into the food container of particular kind, you must call addGatheringInfo method and pass game time when this item was gathered and a number of pieces. This will add a new record to the GatheringInfo collection. If you want to see how many food items of this kind are fresh at a given game time, call getCountNormal and pass game time you want to test against. Most of the time it is current game time. getCountSpoiled will tell you how many pieces of food are spoiled at a given time. Inventory item name can contain special information that will be interpreted by the getByName method of inventory controller. Food item has such a special postfix, $spoiled. If you pass clean food item name without any postfixes to the getByName method, for food items you'll get only the fresh part of it, a new instance of this food item with count equal to the count of fresh item at a given game time. Is spoiled property of this returned item will be set to false. If you passed food item name with a spoiled postfix like meat $spoiled, you'll get only spoiled portion of a food item, a new instance of this type with count equal to the count of spoiled food pieces of this kind at a current game time. Is spoiled property of this returned item will be true. To take a piece from fresh group of a food item, call take one from normal group and pass current game time. To take a piece from a spoiled pile, call take one from spoiled group, similarly passing current game time. That's what inventory controller does on try-use call for a food item. We'll discuss using inventory items in a bit here. Inventory controller on a get-by-name call looks if a given name contains a $sign, and if it does, calls process special get that looks more closely into the name given and does its custom analysis. At the moment, only food items got the special treatment. To summarize, food item is a container that has a collection of gathering info, how many pieces of this particular food and at what time has been gathered. Using food item-based methods, you can check how many pieces of food are spoiled at a given game time. You can take from fresh or spoiled piles and, of course, add in new pieces of food to this food container with add-gathering-info call. In other words, if you already have meat item in the inventory, you don't call add-item to add a new meat piece. You call add-gathering-info on the already existing meat item instance. Okay, what about water? Water operates on a similar basis, but much simpler. It does not have fresh spoiled mechanics, but has its unique features too. Every water item in the inventory is a water vessel item base, that have some known capacity, number of doses in it. It has water vessel weight itself and a weight of 1 dose, and final weight is calculated as water vessel weight plus dose weight multiplied by the doses count. It has properties like doses count, overall capacity, doses left, how full this water vessel is, vessel weight in grams, water dose weight in grams, and weight grams per unit, which is the current weight of this item, calculated on every call. Water items have safe-unsafe mechanics. When you fill out the vessel, fill up call, it resets its safe property to false and remembers last fill game time. Doses left are maxed out now. You can call disinfect, which will set is safe to true and remember last disinfecting game time. If you call fill up when item is safe, it will become unsafe. You can also boil the water, call boil, and it will set is safe to true and will remember last boil time and will set last disinfection time as well, because boiling equals disinfecting by Zara logic. Fill up call resets last disinfection and last boil times. You can call take away 1 dose to decrease doses left count. If no doses left, this call will not do anything. Name postfix property will return a $sign postfix for this water vessel item. It will contain its safe status and doses left like $sign safe free or $sign unsafe 5. It is not used in Zara anywhere, it is just for you to maybe get differing inventory icons for different water vessel states. If you give get-by-name water vessel's full name with postfix, it will just ignore the postfix and return item from the inventory as is. Now we know something about food and water, let's look how we use items in Zara. To use item mean to eat, including pills, to drink or to take an appliance. More on taking appliance in a body controller episode. To use an item, you must call try-use method of the inventory controller. This method, like many inventory methods, accepts check-only parameter as well, which, if set to true, will only simulate the action, return the result, but will not do anything to the inventory. The method returns an object, item use result. It consists of an item that was used and a result, which is a simple enum. Value can be used single, when after using the item it still remains in the inventory and is not empty. Used all, when you used the last item or last piece inside the item for food and water. Insufficient resources, if you tried to use an item but no such resource was found. For food items, for example, you requested to eat spoiled piece, but no spoiled pieces left. And finally, unapplicable. If you try to use an item that is not any kind of consumable, medical consumable or appliance, try to use, for example, knife, and you'll get this result. Try use accepts not the item name, but inventory item itself. It is assumed that item will be acquired by the get-by-name method call, before being passed to the try use. If food item use is requested, Zara will look if item is spoiled. If it is, it will take one piece from the spoiled pile of the food item, will notify the health engine, and return a result based on the rules described above. If fresh food item use is requested, Zara will look if food item has any fresh pieces. If not, it will try to use spoiled piece as described above. If the fresh piece was found, it will take one from the fresh pile of the food item, will notify the health engine and return a result. If after using the food item no more pieces left inside, food item will be removed from the inventory. After using food item, you may consider to refresh the rough inventory weight if it's something that you use in your project. When water vessel item use is requested, Zara will look if item has doses inside. If not, insufficient resources will be returned. If water vessel is not empty, Zara will take away one dose, will notify the health controller and return a result. If you use the last dose in a water vessel, item itself will stay in the inventory and used all will be returned. Using water item will never result in removing it from the inventory. If medical consumable use is requested, an item whose type is medical and medicine kind is consumable, Zara will look at item's count property. If it is not 0, Zara will notify the health engine, decrement item's count, and if this count became 0, will remove this item from the inventory. If a given item is an appliance, type is medical and medicine kind is appliance, it will simply check the count, decrement it, and if needed, will remove item from the inventory. It will not notify anyone, because actual appliance logic is handled by the game developer, and we'll talk about this in our body controller related video. There is also a waste item method. This method gets rid of a given amount of inventory item kind. It receives item instance, count that must be wasted, and a check-only flag that, if true, will only simulate the action. Result is an object that tells you was this action succeeded or not, or you try to waste more than you actually have. Waste item method expects to receive inventory item originated from a getByName call, and for food and water items operates exactly how try_use does. But with one exception, waste item will not notify anyone, it just gets rid of resources. You can pass to waste item anything, and it will get rid of it or its part. If by the end of all checks item count becomes 0, waste item will remove item from the inventory. Exception is a water vessel. Infinite item also will never be removed by try_use or waste item call. Well, that's it for using the items. Now we can finally look at crafting. Let's start with defining a crafting recipe. If you go to the Inventory, Combinatory, Inventory Items Combinatory Factory class, you'll see in its constructor all the crafting recipes currently registered. To declare a new crafting combination, you can use a simple Fluent language that goes as follows. You write Combinatory Item Builder, then class of a resulted item, is class of first item in a combination with optional count, and second item class with optional count, like this. Item order doesn't matter. What if you need not 2 items in a combination, but say 3 or maybe 10? You write Combinatory Item Builder, then class of a resulted item, is class of a first item in a combination with optional count, plus class of an item with optional count, plus again, and again, and again, and end with and, passing the final item class with optional count, like this. You can define validation function for any combination. When you try to craft this combination, as we'll discuss later here, this function will be tested, and if validation is not satisfied, crafting will not be performed. To define a validation action, you end not with AND, but with validation method, and pass there a function that receives a list of all inventory items character has at the time of this call, and a Zara character object itself, where you can look at anything you want, health, weather, clothes, everything. This function must return a boolean, true if validation is passed and combination is allowed, and false otherwise. There is one more possibility to make a combination. What if combining two or more items should result not in a new item, but in some kind of action instead, like lit torch plus water flask equals an action that extinguishes the torch, or unsafe water flask plus disinfecting pellets equals action to disinfect the water. In this case, you end your crafting recipe with special action method. You pass here item combination, special actions enum value, and after that call available when function. This one is a validation function for this special action and receives a collection of all inventory items character has at the time of this call. This function must return true if action is allowed. To create a new action, you must add a new entry to the special actions enum. Then go to the inventory special action processor, and in a process action method, add your check condition and a handler method that will do what this action is supposed to do. This class has access to Zara characters, so you have ability to see all characters' data via the private _gc field. Special action handler must return an object that describes is this action allowed, late validation, did this action make any changes, and waste info, same object that waste item method returns. At the moment, Zara's crafting mechanism only looks at is allowed property, so you may leave waste info property empty in this particular case. So, we just learned how to describe a crafting combination, validate it, and assign to it custom special action handler. Next, let's see how to perform crafting. Let's assume you have some inventory items selected in your game and you want to craft with them. First, you need to know what combinations are registered for these items. You call inventory items combinatory factory instance get matched combinations and pass there a list of your items. What you'll get in return is the list of all combinations found for these items. It is a complete match. I mean, if you have 3 items in hand, it will not return combinations with only 2 of them. All returned combinations will contain all 3. Every combination has its ID. It is ID of an instance, so it will change every game session. Next, you want to check which of these combinations your player can actually craft. You must perform resources check. For each combination, you call check combination for resources availability and pass their combination itself or a combination ID. To see if this combination can be executed, you must look at the result property of the returned object. If this property value is allowed, you can execute it. Or for short. Then you end up with a list of combinations that player can execute right now. You pick one, and to execute it you call try combine, pass a combination ID and a flag check only. If it's true, no actions will be actually done and method will only simulate the work and return a result as if combination was executed, so you can test run this combination before actually executing it. On success, if a combination produces some item, this item will be automatically added to player's inventory. Resulted object will contain a result property, one of enum values. On success, it will contain allowed. Resulted item itself, just for reference, item, if any, was already added to the inventory at this point. Flag that tells you if this combination resulted in a special action. And a detailed report of wasted resources, so you can see exactly which resources and in what amount has been spent to execute this combination. That's it. This is how you craft with Zara. For any detailed info on any topic of Zara, refer to Zara Wiki. It contains thorough description of everything with direct links to its source code. But today we managed to cover in depth everything inventory related. In the next video, we'll take a good look at body controller, appliances and player clothes. See you in the next episode.